Okay, now that we got the basics down, let's take a look at a graph that's going to be a little bit tougher. Look at what I have right here. I have 2x minus 8. Now, you remember through our old formula of y equals mx plus b, right? We have this being slope, this being the intercept. So we have an intercept of minus 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. There's our point. And there's our slope, which is rise over run, which is 2 over 1. So we can go up to 1, 2 over 1. And what I want you to do here is I want you to notice that this should go down something that looks a lot like that. Okay, there's our beautiful line. Now, here's something that's interesting. We have to graph the reciprocal function. Well, let's clean this up so I can actually read this again because I got scribbles everywhere. There we go. Okay, so we're going to graph the reciprocal function of this. That means 1 over f of x. But wait a second. How do you do a reciprocal of an equation? Well, easy. That's over 1. So this equals to 1 over 2x minus 8. There you go. There's the reciprocal function. Now, here's the problem with that, though. Look at the problem. The problem is now something here could actually cause the denominator to be 0. And of course, we know that as an NPV, a non-permissible value. So let's figure out what that non-permissible value is. Cannot equal to 0, add 8 to both sides, boom, boom. This gives you 2x, cannot equal to positive 8, divide by 2, right? X cannot equal to 4. But I want to show you something, because look, 1, 2, 3, 4. That point where the original graph goes through the x-axis is actually your non-permissible value. Isn't that cool? So you can draw your asymptote right through there. There's your asymptote at x equaling to 4. There's your asymptote. And all you have to do now is draw the reciprocal function. And the reciprocal function is always going to look like this. There's your reciprocal. Remember, we drew it in the last podcast. There's your reciprocal function. Done. That's all you have to do to draw these things. Pretty darn easy. Well, let's see if I can confuse you a little bit. Nah, I'm going to just open this up. I want to look at something called reflecting. Now, do you remember parabolas? When the a value was positive, it opened up. And then when the a value was negative, it opened down. We call it the unhappy parabola, if you remember correctly. Okay? The unhappy parabola opening down. So what we do is we call this actually, if you look at it, this is opened up. All we did was we used the x-axis as a mirror and we flipped it upside down. Does that work for this? Now we've got another function here, which is minus 3/4 x plus 6. So let's graph this thing first. Okay, so move this along. Minus 3/4 x, there's a bracket around this, plus 6. So let's start at the intercept. 1, 2, 3, 4, 5, 6. There it is. Minus 3/4 means down in terms of a rise and over 4 in terms of a run. So down 3, 1, 2, 3, over 4. 1, 2, 3, 4. So if you look at this guy, it should go out to about like this. Something like about like that should be the line. And of course, if you look and if you drew this properly, look, 1, 2, 3, 4, 5, 6, 7. Right here is going to be your asymptote. Right there is going to be your asymptote. Let's prove that that's actually the asymptote, which I'm going to predict is going to be x equals to 8. Let's prove that right now. So how do you do this? Well, let's look at the reciprocal function of 1 over f of x. So in other words, 1 over negative 3/4 x plus 6. And we know that negative 3/4 x plus 6 better not equal to 0 because why? It's not permissible. It's an NPV. So what do? Okay, let's subtract 6 from both sides, giving you negative 3/4 x equaling to negative 6. Now, we're going to divide each side by negative 3/4. Divide by negative 3/4. Now, if you can't do that, I'll prove something to you. Bring up the calculator. Here we go. Boom. Okay, let's go over to here. Okay, there it is. Second quit. Okay, there it is. So we're going to go negative 6 divided by bracket negative 3 divided by 4, negative 3/4. And let's see what we get. Boom. 8. Look at that. I was bang on. X cannot equal to 8. There it is, sports fans. I predicted it right off the bat. Woohoo! Now, the question is, what is this graph going to look like? Because remember, this originally is now coming in from a negative direction. It's giving you a negative slope. So what's it going to look like? Well, I'm going to show you. Real easy thing to do. Bring up your calculator. Boom, like this. Let's go into y equals 2, and let's actually put this reciprocal function into the graph. So what do we have to do? Well, we know it's going to be 1 over, but don't forget, we're going to need brackets around this, and we want this whole thing under the 1. So we put brackets around the entire thing. So look at all the brackets we're going to have. This one, this one, this one, and this one. So we're going to have brackets all over the place. That's really important to watch. Okay, here we go. So it's going to be 1 divided by bracket, bracket, right? Negative 3 divided by 4. There's our fraction. There's our slope. X plus 6, and just don't forget to finish the last bracket. That's why I tell students, always draw this out. Always write this out before you put it into a calculator. It's really going to help you. Okay, ready? Let's graph it. Let's see what it looks like. There's our grid, and look at that. Beautiful. And guess where? Right at 8. Right at 8. So it's going to look, but why is this different then? Remember, I always said that graphs should look like this, right? It should look like this. But remember, I'm talking about the parabola now being negative, which means it's flipped. This was this way, but now it's flipped. It was going up here, but now it's flipped. It's reflected along the mirror line. The mirror happens to be, guess what? The mirror happens to be that's right, x-axis. So instead of it being here, what you have to do now is you have to flip it and put it, guess where? Here. There it is. Instead of it being here, you have to flip it and put it, that's right, right here. And that's what it's going to look like. So let's clean this up a little bit. Let's make it look really, really decent. I'm going to erase the whole thing. Okay? Come on, here it goes. Any second. There it goes. It's gone. Remember what our asymptote was? 1, 2, 3, 4, 5, 6, 7, 8. Right here. Because of this negative value of slope, our asymptote is still here, but now we have to look like this. This way and this way. So let's do a little bit of a summary here. Let's add a page. Our summary is going to look like this. All right, here's our summary. At f of x equaling to some y equals mx plus b, when your slope is positive, you're going to get a graph that looks like this. That becomes your asymptote, okay? Because that's going to be your non-permissible value. And when it's positive, great. You're going to get a graph that looks like what? You're going to get a graph that looks like this. Boom, boom, right? Okay, now, when your slope is negative, though, okay, you're going to have, again, the same non-permissible value, whatever the non-permissible value is. So if you've got a graph going like this, there's your non-permissible value right there. Same stuff as before, but now because it's negative, this graph is now flipped. So being that it's flipped, it's going to be here, right? And don't forget to flip this one. And it's going to look like that. So you have 2 different possibilities, all based on the fact that this could either be positive or negative. Really important.